Are you trying to use ROS2 directly with CARLA, but things just don't work as expected? In this video, I'll show you how to run native ROS2 in CARLA step by step. No ROS bridge confusion, no version mismatch headaches, just a clean, low latency setup handled directly on the server side. This approach is cleaner, faster, and ideal for research and ADAS workflows. If you're working with CARLA or ROS, consider subscribing for practical tutorials like this. Let's get started. Open your browser and go to the CARLA Simulator GitHub repository. You can simply search for CARLA Simulator GitHub. Once you're on the repository, click on the Releases section. In the latest CARLA release, version 9.16, you'll see a new feature called CARLA Native ROS2. This means we no longer need the CARLA ROS Bridge because everything is now handled directly by the CARLA server itself. Before continuing, make sure you are using CARLA version 9.16 or newer. As you may already know, there is a separate CARLA ROS Bridge GitHub repository. If you check it, you'll notice that there is very little recent activity. It's mostly inactive now. So going forward, we should use CARLA's native ROS2 support instead. CARLA currently provides only a few minimal examples for native ROS2. You can find them under Python API, then Examples, and then in ROS2. These examples are useful, but for real use cases, we often need many of the nodes that were available in the CARLA ROS Bridge. That's exactly what we're going to cover in this tutorial. Now, let me switch to my local CARLA installation. This setup is built from source. I'll quickly check the current status using git status. As you can see, I'm on the UE4 development branch. If you go to the CARLA ROS Bridge GitHub repository, you'll notice that it contains many useful nodes that we commonly rely on. However, these nodes are not fully available in the current CARLA release by default. So what we're going to do is head over to the main CARLA repository and look at a specific pull request. If you open the pull requests section, you'll see a pull request like the one shown on the screen. This is exactly what we need. If you read through the description, you can see the changes made on the CARLA server side. These changes allow us to use almost all the nodes from the CARLA ROS Bridge, but through native ROS2 support. At the moment, this pull request has not yet been merged into the main CARLA repository. So when you install CARLA on your system, make sure to first check whether this pull request has already been merged. If it has been merged, you can skip this step. At the time of recording this video, it has not been merged, so we need to pull it manually. I'll copy the pull request number and pull it into my local CARLA repository. As you can see on the screen, the pull request is now being fetched. Before checking it out, I have a few local changes, so I'll stash them using the git stash command. Now I'll check out the pull request. Next, just like a normal CARLA source build, we need to build the Python API. I'll run the make Python API command. This step may take some time, so I'll fast forward through it. Once the Python API build is finished, we can move on to the next step, which is launching CARLA. Here, there is one important difference. Unlike earlier cases, we need to pass an argument to the make launch command, specifically for ROS2. Pay close attention to how I run the make launch command on the screen. This step may take some time depending on your system configuration. If you need help with this, I've already made an earlier video that explains how to install CARLA from source both on Windows and Linux. Feel free to check that video out. In my case, I didn't run into any errors, so I'll fast forward this part of the video. Let's wait for the Unreal Engine editor to open. After a short while, the Unreal Engine editor starts. I'll choose Town 0.1 as the map, because Town 10 is a bit too heavy for my system. I go to the CARLA folder, open the Maps directory, and then double-click on Town 0.1. This may take some time to load, and it may also take a while to compile all the shaders. Once the shader compilation is finished, I start the simulation by clicking on Play. Now the CARLA server is running, and the first part of the setup is complete. Next, we move on to the second part. For this, we need the CARLA ROS Bridge repository. If you don't already have it on your system, go ahead and clone the repository using the git clone command, as shown on the screen. Once the repository is cloned, open the pull requests section. Here, you'll see a pull request that we need. Just like before, make a note of the pull request number, fetch it, and then check it out locally. After that, we build the workspace using the colcon build command. During this step, I initially ran into an error because I hadn't cloned the required submodules. The CARLA ROS Bridge includes a CARLA Messages submodule, so make sure to initialize and update it using the command shown on the screen. Once that's done, run colcon build again and wait for it to finish. Now the build completes successfully. At this point, we can open the workspace in Visual Studio Code and take a look at the available nodes. As you can see, almost all the nodes from the original CARLA ROS Bridge are available here. Before running anything, make sure to source the workspace using the command shown on the screen. Now, let's launch one of the sample launch files. After a short while, the Pygame window opens with manual ROS control. This should look very familiar if you've used the CARLA ROS Bridge before, except now everything is running directly on the CARLA server. There's no extra ROS Bridge overhead. Let's open a new terminal tab, source the workspace again, and run ROS2 topic list. As you can see, all the expected topics are available, including sensors, vehicle control, ego vehicle speed, and many others, just like the traditional ROS Bridge. If we echo one of the topics, we can inspect the messages being published in real time. At this point, it's important to note that native ROS2 support in CARLA is still a work in progress. You can expect more commits, improvements, and new features to be added over time. I'll keep sharing updates on this channel, so make sure to subscribe if you want to stay up to date. Thanks for watching, and I'll see you in the next video.